This is the Chapter 4 assignment video. Problem number 1 is a probability distribution, and we are just asked to fill in the missing probability. So we had all these other probabilities, and we know that the total of these has to total 1. So that meant that the missing probability here had to be 0.17 so that all of these totaled 1. The next part of the question asks to describe the shape of this distribution. If I were to make a histogram out of this, so here is all the number of dogs per household, so 0 dogs, 1, 2, 3, 4, and 5 dogs, and my vertical axis is these probabilities, so going up to 50%. Looking at our number of dogs per household of being 0, the probability of that happening is 50%. So here's 0, so this goes up to the 50%. 1 dog is about 25%, and so on. So this is roughly drawn here, but you can see that there's this tail that's pulling the data over here to the right. So we would call this right-skewed data. The second question is another probability distribution problem, and this problem says a bank president feels that each savings account customer has on average 3 credit cards. The following distribution represents the number of credit cards that people own. Use your formula or calculator or StatCrunch to find the mean and the standard deviation. So this is what we are given, this probability distribution, and all the customers were asked how many credit cards did they have, and the answers ranged anywhere from 0 to 4 credit cards, and this was the probability of how that might happen. So if they called up a customer, the probability that they asked the customer and said, hey, how many credit cards do you have? And they said 2, the probability of that happening would be 25%. So this is what's given here. Now this column here is what I added. So we're asked to find the mean of this probability distribution. So the formula for that, this little sideways looking M is actually called, the symbol for the mean. It's actually mu is how we say that. It's called mu. But it's equal to the sum of, this symbol means the sum of all of the x times the p of x's. So that's what I did. I made a column here for all of my x's times my p of x's. So 0 times 0.15 is 0. This x times this p of x, 0.47. And this x times this p of x is 0.50, and so on. So these are all my x times p of x's. And then if we sum them up and total all these up, we add these together, and we get 1.39. So that's all I've showed you here. So the specific formula to find mu, or the mean, is just the 0 times the 0.15, which is this, plus 1 times 0.47, plus 2 times 0.25, and so on. So if we do all the math and add all that together, we do get the 1.39. Now, the formula for the standard deviation is a little bit harder to use, so I wanted to show you guys how to use StatCrunch. And of course you can use StatCrunch when you're taking your test as well, and it's available when you do your homework. So I've got StatCrunch pulled up over here, and this is what we will do. In this first column here, we're going to put our x's. So the number of credit cards is what we had here. So 0 credit cards, 1, 2, oops, got a typo there, 2, 3, and then 4. That was all the possibilities of number of credit cards we could have. And these were the probabilities in that second column associated with each one. And I don't have any typos. There we go. Now the way to find the standard deviation is we go to Stat, Calculator, and then we go all the way down over to Custom. And I have that here in the notes too. It's in your other notes as well, but I have it here at the bottom of the page. Values, it So that's our first column is in var 1. We've got these values in here in this first column that we're calling var 1. The weights or the probabilities are in var 2. And all we have to do is hit compute. Now this is a funny little readout, and we're going to learn a little more about what this means. But right here is your mean, which is what we got a minute ago when we did it by hand. We got 1.39. And then it also gives us a standard deviation right here. So we would say 0.96. I rounded to 2 decimal places. So just be careful on your homework that you pay attention to how many decimal places it's asking for. It might say round to 2 decimal places, or it might say something like round to the hundredths place or round to the thousandths place, something like that. So just be aware of how it wants you to enter the answer in your homework. Turning the page. And the next problem, problem number 3, we're going to also use our binomial, we're going to use the binomial calculator, not this custom one, but we'll use the binomial calculator. So let's look at the problem. We have, it says 70% of households say that they would feel secure if they had $50,000 in savings. So you randomly select 8 households and ask them if they would feel secure if they had $50,000 in savings. So it's telling us we need the binomial, this is a binomial probability situation. So we can use the binomial calculator in StatCrunch. And one way that I know this is binomial, other than it's written here in the problem, is that we're looking at what's going on here with the problem. So we are asking households, and we are asking them, would you feel secure or would you not feel secure if you had $50,000 in savings? So there's only 2 outcomes. So that's the binomial part. The outcome is yes, I would feel secure, or no, I would not. So it's like success and failure, 2 outcomes. So the first question asks, if a group of 8 households are randomly selected, what's the probability that 0 households feel secure if they had $50,000 in savings? So let's see how that would look. Let's go to StatCrunch. This is a binomial calculator, so let me just clear all this out. Stat and new data table. And then stat calculator binomial. Before we went down here to custom, but now we're going to use the binomial calculator. So N is the number of trials. So in this case, it's how many people are we asking? So N is 8. We're asking 8 households. P stands for the probability of success. And so we're already told that we know that 70% of households would feel secure if they had $50,000 in savings. So P is 70%, 0.70. So let's take a look at how this would work out. So part A says, I'll go ahead and we'll leave this here for now. So part A says if a group of 8 households are randomly selected, what's the probability that 0 would feel secure if they had $50,000? So if the probability that X would be equal to exactly 0 households. So if you hit compute, that's really, really small. It's not very likely because we already know that 70% say they would feel secure. So the probability of asking 8 people and nobody feeling secure is pretty low. It's almost 0 actually. So this is, I just rounded out to this decimal place right there. The next part says if 8 are randomly selected, what's the probability that at least 1 household feels secure? So at least 1, we have to figure out which inequality symbol here represents at least 1. So at least 1 means it could be 1 or it could be more than 1. So this is why I chose greater than or equal to 1. If you hit compute, that's a really good chance that at least 1 would say, yeah, I'd feel secure if I had $50,000 in savings. So that's almost a sure thing. That's almost 100% chance. So 0.9999. Part C is asking it a little bit differently. It's saying if a group of 8 households are randomly selected, what's the probability that less than 5 would feel secure? So less than 5 is the less than symbol. Changing this to 5 and hitting compute, and that's about a 19% chance, rounding to 2 decimal places. So what's important to note here is the wording sometimes. At least 1, less than 5, that 0, so that would be exactly equal to 0. This is At least is greater than or equal to less than. Okay, the last problem is problem number 4. And it reads, assuming that 85% of Pellissippi students drink carbonated beverages at least once a month, and we're going to assume that, given 150 students are randomly surveyed, find the following. Use formulas. All right, so the formula to find the mean when you have a probability, binomial probability, would be n times p. That's just the formula, that mu is equal to n times p. So n was 150. That's how many people we're asking. P is 85%. So that's simply 150 times 85%, which is 127.5 people. All right. The standard deviation, the formula we need is the square root of n times p times q. Now q up here is whatever 1 minus p is. So p was 85%, and that was given to us right here in the problem. So q has to be 1 minus 0.85, which is 0.15. So we know that p and q always add up to 1, or 100% chance. This is success. Q is considered failure. So it's either going to be one or the other. Either you drink carbonated beverages or you don't drink carbonated beverages. So to find the standard deviation, we simply take the square root of n times p times q. And I wanted to show you, I'm going to try to drag this calculator over here, how you could do that on your TI calculator. So I have a square root button here right over this button. So I'm going to second square root. And then I'm going to do 150 times 0.85 times 0.15. And see how it started a parentheses here for me? On this particular calculator, I need to close it. Then hit enter. So that is the standard deviation, 4.37. Now, something else that we like to consider is, if we surveyed 150 people and we asked them, hey, do you drink carbonated beverages? We like to consider what the minimum and maximum value would be to be considered normal or usual. So, in other words, how many students would say that they drink carbonated beverages? How many would that have to be for us to say, that's a weird group of students. They really, really like to drink carbonated beverages, or they really, really do not. So what are those minimum and maximum values that we would consider to be unusual? So the formula for that is, to find the minimum, you take the mean, which is mu, this little sideways m, minus 2 standard deviations. This is a sigma. So more specifically, so we would put in the mean, which we got up here, the 127.5, minus 2 standard deviations. So here's the math, and this would be the answer that we get when we do the computation right here. So that would be, if we ask 150 students and we got something below this value, that would be weird. So if we ask 115 and we only get 100 that say they drink carbonated beverages, we would say that that's unusual in statistics. On the other end, the maximum value would be taking the mean and adding on 2 standard deviations. So how would that look? Here's the mean, which we got up here, 127.5, plus 2 times 2 standard deviations, so 2 times the 4.37 that we got up here. Doing that math, we get 136. So that means if we ask those 150 students and we got something greater than this value, we say, let's say we got 145 students said they drink carbonated beverages, that would also be unusual. That would be an unusually high number. Anything above this. Anything below this would be an unusually low number. So the next question says, is 120 students drinking carbonated beverages at least once a month? Is that considered usual or unusual? Well, let's look. So 120 would be in the middle here somewhere. So it would just be a usual value. That would be completely normal and expected.